Why do landscapes look the way they do? Geomorphology is the scientific study of landforms and the processes that shape them. The Earth's landscape is dynamic and built up over a long period of time, built up through tectonic uplift and volcanism, and then worn away by erosion and weathering. Landforms evolve in response to a combination of a number of factors and operate on many different scales. Geomorphology focuses on the interconnectivity of processes responsible for most topographic features, including wind, waves, glaciers, tectonic plates, and volcanism. 4.6 billion years ago, meteors collided with each other to form Earth. This collision created Earth's molten core, which reaches over 25,000 degrees. That's pretty hot. As a hot core cooled, cracks formed along the outer crust, and these cracks form the boundaries of tectonic plates we see on the Earth's surface. Tectonic plate consists of the Earth's molten asthenosphere and solid lithosphere. They move atop the asthenosphere like graham cookies on top of pudding. The heat from Earth's formation is still trapped in its molten core as we speak. The rising heat forces plates apart in some places and together in others. These are known as plate boundaries. When plates pull apart, a divergent rift is formed. Volcanic eruptions occur here. When continental plates collide, mountains rise. When continental plates and oceanic plates meet, this causes subduction, where the denser ocean crust is thrust beneath the lighter continental crust. A transform boundary occurs when plates slide past each other. This causes the earthquakes and faulting as we see along the San Andreas Fault. Folded mountains are the most common type of mountain, representing the world's largest ranges. Some of the more famous ranges include the Rockies, Andes, and the Himalayas. This science experiment helps demonstrate how they're formed. What you'll need are some towels and a stack of books. Start by laying down a stack of towels, each one folded in half. Then put some books on either side of the towels. The books represent the continental plates, while the towels represent the buildup of sediment on the sea bottom. Now push the books towards each other and observe the mountains being formed. Fold mountains occur near convergent or compressional plate boundaries. Plate movement creates fold mountains as the plates move towards each other. This movement causes layers of sedimentary rocks on the ocean floor to become wrinkled and folded. These mountains are found between two continental plates. The Aeolian process pertains to the activity of the winds, and more specifically, the wind's ability to shape the surface of the Earth. Winds erode rocks and soil surfaces and transport material. Winds also power ocean waves and currents that shape the coast. Although water and mass flow tend to mobilize more material than wind in most environments, Aeolian process are important in arid environments, such as the desert. Rivers and streams are not only conduits of water, but also of sediment. The water, as it flows over the channeled bed, is able to mobilize sediment and transport it downstream. Gravity drives the flow in streams and generates large volumes of material for the streams to carry off the land. Precipitation provides the water that transports sediment off the continent. The water in rivers and streams carries sand to make beaches and carve deep gullies through steep rock canyons. Rivers are also capable of eroding into rock and creating new sediment, both from their own beds and also by coupling to the surrounding hill slopes. In this way, rivers are thought of as setting the base level for large-scale landscape evolution in non-glacial environments. Rivers are key links in the connectivity of different landscape elements. Glaciers, while geographically restricted, are effective agents of landscape change. Gradual movement of ice down a valley causes abrasion and plucking of underlying rocks. Glacial erosion is responsible for U-shaped valleys as opposed to V-shaped valleys of fluvial origin. Marine processes are those associated with the action of waves, marine currents, and seepage of fluids through the sea floor. Mass wasting and submarine landsliding are also important processes for some aspects of marine geomorphology. Because ocean basins are the ultimate sinks for a large fraction of terrestrial sediments, depositional processes and their related forms are particularly important as elements of marine geomorphology. Here's a fun experiment you can do at home to simulate erosion. What you'll need is some sand or dirt, a pan, some rocks, a cup of water, and some books. Start by pouring some sand into a pan so it makes a layer 2 to 3 inches deep. Smooth it out so it's even as possible. Using the sand, create some landforms in the middle. Create a trench at the bottom to imitate the ocean. Slip 2 or 3 books under one end of the pan so that it is propped up on one end. Using a cup or plant starter with a hole at the bottom, slowly pour water over the top of the pan to simulate rain. After all the water is poured, what do you observe? The world is constantly changing. Ongoing global environmental change, including atmospheric warming and sea level rise, are currently driving global change, including coastal erosion, an ice sheet, and glacial retreat. Geomorphology is a major key to environmental management. The applications of the study of the land can be used for restoration, conservation, and even assessing the presence of water on Mars.